Good morning to all. Now we have discussed about the manufacturing technology, metal casting process. So, how do then the metal casting process? So, what the usage of the metal casting process? It is a manufacturing technology is mostly used for that casting process in industries. So, we have discussed about the metal casting process. So, casting is one of the oldest manufacturing process. It is the first step in making most of the products. So, various steps is there. The first step is making mold cavity. Then next one, material is first liquefied by property heating in a suitable furnace. Then liquid is poured into a prepared mold cavity allowed to solidify, and product is taken out of the mold cavity, turned and made to shape. We should concerned on the following for the successful casting operations: and preparation of mold of patterns, then melting and curing of the liquefied metals, then solidification and further cooling to room temperature, then defect and inspections. So the advantage is molten material can flow into very small sections, so that the shape can be made by this process. As a result, many other operations such as machining, forging and welding can be minimized. So possible to cast practically any materials, for example ferrous or non-ferrous metals. The necessary tools required for casting molds are very simple and inexpensive. As a result, for production of small lot, it is the ideal process. So there are creation parts like turbine plates made from metals and alloy that can only be processed this way. So the turbine plates fully casting plus machinings. Size and weight of the product is not a limitation for the casting process. So various types, various limitations is there. So the first one is dimensional accuracy and surface finish of the casting made by sand casting process are a limitation to this technique. Many new casting processes have been developed which can take into consideration the aspect of dimensional accuracy and surface finish. Some of these processes are die casting process, the investment casting process, vacuum self molding process and shell molding process. So metal casting is a labor intensive process, then automations, etc. So typical sand mold is, so important casting terms: the metal or wood frame without fixed top or bottom in which the mold is formed depending upon the position of the flask in the molding structure. It is referred to by various names such as drag lower molding, flask scope, upper molding, flask check, so intermediate molding, flask used there, pieces molding. So patterns, so it is the replica of the final object to made. The mold cavity is made with the help of patterns. So parting lines, this is the dividing line between the two molding flasks and that makes up on the mold. And molding sand which is a main raw material in the casting process. So binding strongly without losing it is the permeability to air or gases. It is a mixture of silica sand, clay and moisture in appropriate properties. Then facing sand, the small amount of carbonaceous material sprinkled on the inner surface of the mold cavity to give you a better surface finish to the castings. core. We then a separate part of the mold made of sand and generally backed, which is used to create opening and various shaped cavity in the castings. The curing basin, a small funnel shaped cavity at the top of the mold into which the mold metal is poured. The passage through which the molten metal from the pouring basin reach the mold cavity, if many cases in control the flow of metal into the mold. Gate is main important in the casting process. The channel through which the molten metal enter the mold cavity. The chapels are used to support the core inside the mold cavity to take care it is own weight and overcome the molded forces. The column of molten metal placed in the mold to feed the casting as it shrinks and solidifies. The feed cut is there, and small opening in the mold of facilities escape of air and gases. Then step in making and castings. The 6 basic steps in making sand casting process. And first one, pattern making, then core making, then molding, then melting and pouring, then cleaning. First one, pattern making. So pattern to be cast and is used to prepare the mold cavity. It is the physical model of the casting used to make the mold made of either wood or metal. The mold is made by packing some ready formed aggregate materials such as molding sand surrounding the pattern. When the pattern is withdrawn, it is input provide the mold cavity. The cavity is filled with metal to begin the casting. If the casting is to be hollow, additional patterns called pores are used to form the cavities. So then core making. Core makings are placed to a mold cavity to from their interior surface of casting. Thus the avoid space in filled with molten metal and eventually begins the casting. So then molding is so nothing but the mold preparation activities for receiving molten metals. So molding usually involves first one is preparing the consolidated and sand mold around a pattern held within a supporting metal frame. Then next one, removing the pattern to leave the mold cavity with pores. So mold cavity is the primary cavity. Then the mold cavity contains the liquid metal and it acts as a negative of the desired product. So mold also contains secondary cavity for pouring and channeling the liquid material in the primary cavity and will act a reservoir of the record. So melting and curing. The preparation of molten metal of casting is referred to simply as melting. The molten metal is transferred to the curing area where the molds are filled. Then cleaning. So cleaning involves removal of sand, scale and excess metal from the casting. Cured and sand and scale are removed to improve the surface appearance of the casting. Excess metal in the form of fins, wire spotting, line fins and gates is removed. Inspection of the casting for defect and generally quality is performed. So cleaning is the last step of the casting process. So without cleaning, the product will be not good. That's why used for the cleaning process. And making a simple sand mold, the drag flask is placed on the board. Then dry facing sand is sprinkled over the board and drag arm of the pattern is located on the mold board. Dry facing sand will provide a non-sticky layers. The molding sand is then poured into cover the pattern with fingers and then the track is filled completely. Sand is then tightly packed in the track by means of hand rammers. Pen hammers used first close to dark patterns, and but hammers used for surface remaining are used. The ramming must proper. It must neither too hard or soft. Too soft ramming will generate weak mold, and impediment of the pattern will not to be good. So too hard ramming will not allow gases or air to escape, and hence bubbles are created in casting, resulting in defect called blows. Moreover, the making of runners and gates will be difficult. After the ramming is finished, the excess sand is leveled or removed with a straight bar known as stick rod. When holes are made in the track to the full depth of the flask as well as to the pattern, to facilitate a removal of gases during curing and solidification done by Ventrop. The finished dark glass is now made upside down, exposing the pattern. So half of the pattern is then placed on the track pattern using locating pins. The hope flask is also located with the help of pins. The dry potting sand is sprinkled and over the track surface and the pattern. A spur bin for making spur passage is located at some distance from the pattern edge. Riser pin is placed to an appropriate place. Then filling, ramming and welling of the hope is done in the same manner. The spur and riser are removed and a pouring base in made at the top to pour the liquid metal. So pattern of the hope and track is removed. Then runners and gates are made by cutting the potting surface with a gate cutter. The gate cutter is a piece of sheet metal bent to the desired radius. The core for making a central hole is now placed into the mold cavity in the track, pressed in core points. Mold is now assembled and ready for curing. Then the pattern and the pot to be made are not same. They differ in the following aspects. A pattern is always made larger than the final part to be made. The excess dimension is known as pattern allowances. So pattern allowance is shrinkage allowance and machining allowance. There are mostly two allowances there. First one is a shrinkage allowance. So what is meant by shrinkage allowance? So shrinkage allowance will take care of conjugation of the casting which occurs as the metal cools to room temperature. So liquid shrinkage, that is a liquid shrinkage and solid shrinkage is there. So first one, liquid shrinkage, reduction in the volume when the metal changes from liquid state to solid state. Then riser which feed is liquid metal to the casting is provided in the mold to compensate of the liquid shrinkage. So solid shrinkage is reduction in the volume cast when metal losses. Temperature is solid state. Shrinkage allowance is provided on the pattern to account for this. Then shrink rule is used to compensate solid shrinkage depending on the material contraction rate. The cast irons 1 foot is a 12 inches. actually measure then 12 minus 1 bar 8 inches. So 4 inches will be for considering shrinkage allowances. So shrinkage rule for other materials, gray cast irons. So gray cast iron up to 2 feet. So 2 feet to 4 feet over 4 feet. Then cast irons up to 2 feet. Then aluminium up to 4 feet. Then magnesium up to 4 feet is also there. Then shrinkage allowance depend on the coefficient of thermal expansion of the materials. So simple relations indicate that the higher the value of gamma, so more is the shrinkage allowance for a dimensions. Shrinkage allowance is the freezing temperature and is a room temperature. So machining allowance will take care of the extra material that will be removed to obtain a finished product. In this, the rough surface is in the cast product will be removed. The machining allowance depends on the size of the casting. So material properties, material distortion, finishing accuracy and machining methods. So machining allowance of various metals. So cast iron up to 12 inch, the allowance is 0.25. Then cast steel up to 6 inches, the allowance is 0.3. Then non-ferrous metals, so 8 to 12 inches, the allowance is 0.12. So draft allowance. Then next one, draft allowance. All the surface parallel to the direction in which the pattern will be removed, the tapered slightly inward to facilitate surface removal of the pattern. This is the draft allowance. So general usage is internal surface holes, etc. So typical draft allowance is pattern materials. Is various metals are used. First one is wood. Wood is the mostly used for the pattern in casting operations. The height of the given surface is 1 to 2 inches. Then draft angle is 1. Then draft angle internal surface. The surface is internal and the external surface is there. The external surface is 1. Then internal surface is 1.5. Then metal and plastic patterns is 4 to 8 inches. Then external surface is 0.50. Then internal surface is 1. Pattern having to draft on allowance on vertical surfaces. The casting made using wooden patterns, mostly have to use it for wooden patterns. So assuming only shrinkage allowance, calculate dimension of the pattern. So all the dimensions are in inches. So gray cast irons materials dimension is 2 feet to 4 feet. Then shrinkage allowance is 0.125. Then casting steel up to 2 feet. Then shrinkage allowance is 0.251. Then aluminum material up to 4 feet. So 0.115 allowance. Then magnesium up to 4 feet. 0.173 allowance. The castings using wooden pattern assuming only machining allowance, calculate the dimension of the pattern. All dimensions are inches. So cast iron, cast steel, so etc. Use it. The non-ferrous is up to 4 inches. Then allowance is 0.09. Then core and core print. So core are used to make holes, recesses, etc. in castings. So where coring is required, provision should be made to support the core inside the mold cavity. So core prints are used to serve these purposes. The core print is an added projection on the pattern, and it forms a set in the mold on with the sand core process. So rest during curing of the mold. The core print must be used size and shape so that it can support the weight of the core during the casting operations. So allowances, so hammer allowances. So vertical edges will be curved or disordered. This is prevented by shaped pattern, so converged slide, so that the casting after distortion will have its side verticals. The distortion casting may occur due to internal stresses. These internal stresses are caused on account of cooling of different section of the casting and contractions. So preventions, so providing sufficient machining allowance to cover the distortion effect, providing suitable allowance on the pattern called hammer or distortion allowance in inverse reflections. The tapped hole and slot will not be sand cast. They will be made by machining operations only. The operation showing the made of two as which are located by dowel pins. This is called split patterns. So pattern materials would like easily workable, minimum tendency for checking and warping. So pattern materials. So patterns for sand casting are subjected to considerable wear and tear due to remaining action, that is record, and the abrasive action of the sand should be improved to moisture because of changing surroundings. So made of wood, metal, plastic, plaster and synthetic materials are used for the pattern materials. So the wood should be straight grain, light, easy to work, little tendency to develop crack and wear. So for large casting metals such as cast iron or aluminum have to used. When metal patterns are cast from the wooden moisture pattern, double shrinkage must be provided on the wooden moisture pattern. So assume metal pattern is made up of aluminum and casting are made of cast iron. The shrinkage allowance for the wooden moisture pattern is there. So various material have to used, that is the grey cast irons, cast steel, aluminum, magnesium, etc. So the various types of patterns is there. Then first one is flat pack patterns. So can be used for this in this after completing the mold cavity is either in the drag side or in hope side, or both. The hole is formed by the molding stand. The outside edge around the flat pack is the parting line and it is the sorting place for draft. This is simplest and easy method. Using a track sand core to obtain the core, and this is split patterns. The axis of the hole is vertical, the first case. Consider a solid cylindrical pattern. Above the pattern is placed on the molding board, rammed and rolled over in order to withdraw the pattern from sand. Some of the sand is removed and smooth as is there. This create a new potting surface. Thus a potting line is made with joining potting line around the pattern. The operation of removing the sand and making a new potting surface is called cupping down. The mold is completed by ramming of the hoop in a usual manner. Other methods: cylindrical patterns standing on the end. If it is wear not too long, then cylindrical pattern can be molded using split patterns. Then bending method. So the solid cylindrical pattern can also be molded using bending in method. In this method, first the track is practically filled with mold sand and removed. So after sufficient remaining, the pattern is brushed into sand. In the to have proper ramming of sand, the sand close to the pattern is dug and rammed tightly. Sometimes the pattern is removed and the sand is surface tested for soft spot. In case of soft spots, ramming is so continued with the additional sand till the sand is packed tightly. The pattern is again pressed down to have properly rammed mold cavity. So bending in is down so that the parting line is about level with the surrounding flat sand surface. So whenever a pattern is bended in the drag need to not be rolled over. So bending in can be employed for making larger mold using in pit molding. And flash scope, so sometimes called odd side. So flash scope techniques is another method of molding the solid cylindrical patterns. This is similar to bending in method, except it is not required to ram the sand tightly under the patterns, or the pattern shape is such that it is not possible to ram sand tightly. The patterns is first bended into the hoop without giving importance to the ramming of sand, the pattern and smoothness. The hoop and pattern is then dusted with potting sand and drag part of flash is placed on the top of the hoop. The ramming is then completed in a usual manner. The entire assembly is climbed and rolled over in a sand bed. The clamp are removed and the hoop and hoop bottom board are removed and destroyed. The empty hoop is then placed on the track and the usual ramming is performed. It should be observed that the hoop, the first used is a dummy block for creating the track correctly. This is called flash hoop. Then green sand matches, so that the hooping done operating can be reduced to a greater extent, reducing the cost and time. Take the example like a pattern with a potting line, so not lying in one plane. This pattern should be supported on a mold board at elevate end by a wood piece. Once the ramming, rolling over and hopping down are completed, the drag will look like as a few seconds. So one top of this drag, a green sand match may be removed up extra hard without spur and riser pins. The completed green sand matches with the pattern is placed showing the figures. The sand match is now retained with the uneven potting surface to support pattern and further making of rammed tracks. In general, a gated pattern consists of many small patterns fastened together through gating. Since gates runners are part of the patterns, time and cost are not spent in making them separately. The number of patterns are rammed and drawn from the mold and the same time saving additional time. So first method of making a wheel mold is through 3-pot flash having a middle flash region called check it. Cores for exterior casting surface. So dry sand core can be used for making the grooves. Use of core box is required for making core, which make this method not suitable below certain quantity. For large quantity, this is method is preferred. The overhanging bosses core prints. Dry sand core is placed. The dry sand core part is filled on mold by using the core sand. Using a loose piece. The loose piece is held by using a bent pin. Ramming is done properly around the loosest pieces. The drawback consists of mold that can be drawn back in order to remove the patterns. So drawback is like a green sand core removed by against the mold instead of the making the core box. Once the pattern is removed, the drawback is located in the original place. It is backed up by the additional sand, so that is it will not display during fluid fillings. It also uses the large mold of creating castings. Tins are made of sheet metal shapes that they used with the pattern to make certain initial and internal and external shapes, but at the same time pattern can be removed from the mold cavity. There are thin hollow metal sheet that are attached to pattern before the pattern in rammed up in the sand. So when the pattern is withdrawn, the remains in mold sand should focus into the castings. For ferrous casting, a tin plated sheet steel about 0.012 inch thick is used. So core and core pin have to, inside the pattern have to placed. The casting should be fixed, balanced properly. To long cores cannot be balanced properly. A pattern with a hanging core print is shown for making a pistons. The core in the mold catches a cover for mold cavity and hence scope is not needed. The method of molding two pistons at time having one balanced core. As the mold is filled with molten metal, the chaplet prevents the core to float and move upward, dislocating from its positions. The part of the chaplet mold will be focused into the casting. There are generally made lighter such that the solder unit with the surrounding metal. Tin or copper plated chaplet are used for ferrous casting to avoid rusting. So radiator chaplets having a flat square ends are fixed in the pattern itself and will provide good support to core along with the rammed sand. So ramming a large mold, first few inches of sand over the pattern should be carefully rammed and tightly packed. The soft part should be removed properly. So large mold of considerable depth should be removed larger by layer. Floor rammers that are heavy and measure up to 5 feet long can be used. The molder will stand on the rammed sand. So nowadays, pneumatic rammers is operated by the compressed air with a butt shaped end. So ramming should be done as close to vertical surface of the patterns. So pit moldings. So next, the large casting are made in pit foundry floor. Reinforced material have to use to make sides or bottom of pits. The bending in the technique may be used since rolling over of the drag is not possible. So appropriate placing of pattern is done. So several cores can be used for making die castings methods. So pit molding may be take few days to weeks for completions, and hence binding and added to the molding sand which harden when are dry. So low cast pattern for large molding have been used. So low cast patterns is mostly used for is sweep patterns. Sweep patterns consist of the board having a profile of the desired mold, so which is revolved around a spindle or gate produce the mold. Two are used, one for sweeping the hoop or for drag. So segmental patterns. So metal for circular ring shaped large sections. So instead of the using a full patterns, so part pattern is used. Once mold is done at one place, it is rotated to the adjustment region and molding in patterns. So this consists of a frame of wood responding the interior and exterior forms are used to remove excess sand, which is purposely removed with the extra thickness than required for desired mold surfaces. So binders used in a sand casting for moldless cores. So fire clay, oil, synthetic resins, wood, etc. So natural and synthetic molding sand. So natural molding sand is this is ready for use as it is dug from the ground. So good natural molding sand are obtained from new work, etc. The following average compositions are then in natural molding cast is 65.5% silica grains, then 21.7% clay content, etc. Too much clay content or other impurity fill up the gap between the sand grains. This will hinder the necessary passage of steam and other gases during curing of the mold. Then next one, synthetic molding sand. So synthetic molding sand is made by mixing together specially selected high quality clay free silica with about 5% of clay. So there are tailor made of the given most desirable results. Some of the advantages of synthetic molding sand are actually grain sizes are more the uniform. Then advantage of natural molding sands. So moisture content range is wide. Generally cores are used for making interior surfaces of hollow casting, and nowadays it is used for mixing exterior surface and further purposes. So green sand cores contain ordinary molding sand, and dry sand core contains harness, back or etc. So core mix contains clay free silica sand. There is a suitable mixture with the binding materials like as water and the increased process where resin are used. Then synthetic cores binder has some usual properties like short backing times and the excellent properties are to used in core sand. And core characteristics. So good dry sand cores should have the following characteristics. So good dry strength and hardness after packing. So sufficient grain strength to return the shape before packing. Then surface smoothness. Then lowest possible amount of gas created during the curing of casting. So core dryers. So cores must be supported properly in the green state before the black hardened. The core should be prevented from shaking and breaking. So core dryers may be made also metal casting within this section in order of absorb minimum heat. They are preferred for easy escape of gases and air. For large quantity production, many core dryers are required. So loose pieces is core boxes. Loose pieces are required for cores having backdraft on vertical sides. Such a loose piece will from a enter side of the core. The loose pieces remains on the core, which will be removed later by horizontal movement. So core wires, then core rods, etc. Then small core has sufficient strength after packing to withstand the molten metal, so upward forces. For iron casting, the lifting force is 4 times have weight of the core. Wires are meant for small core, and cast iron or steel based silicon such as removing, that is a removing is there. Sometimes proper the materials plotted together to facilitate easy removals and core winding. So proper core winding is required escape if the cores are surrounded large by molten metals. The core containing binders will produce gases, steam, etc. Because of the heat generated due to molten metal, the gases should be vented out through core prints. So the defect have to produced. So large core are sometimes made hollow shapes. Then core blow machinings. Core blow machines are mainly suitable for large quantity parts of manufacturing. The sand reservoir is first moved below the hopper, where it is filled with the sand. The sand reservoir is then moved to the blow positions. The core box is placed on the table and pressed up with the blow plate. The core box is repeatedly filled with the sand using the blower. At the top of the machines, then compressor at high pressure. Compressor to produce the high pressures. Yes, the air does not to reduce the properties. It is generally understood that because of the blowing operations, larger grains etc. of the core and finger grains at the surface, creating a smoother surface. So core box equipment for core blowing. Core box should be complemented within the core dryers. It is the proper support a blow plate of fastened to the reservoir. Sometimes the sand grains may be conveyed properly due to the presence of entered channels. For continuous operations of the machines, many times are used for greater porosities is there. So upper half of the core box is sometimes used with the blow plate that fastened to the sand magnets. Then core packings. So after cores are made and placed on the core dryer. So then the taken on the breaking. Banking removes moisture and hardness core binders. Generally, core sand is poor conductor of heat and hence the heat penetrations in a core having then in a thick sections. The thin section will be over backed while thick section will be optically packed. The large core will be packed differently on the surface and in interior sections. Then core ovens. So continuous the core ovens are those which are core moving slowly on the conveyor. So continuous loading and unloading is followed, hence the packing time is controlled by the rate of travel of the conveyor. So generally same side cores are used in this process. No movement of core occurs. The electricity and gas, oil, etc. that type of used for heating and temperature is maintained uniform and closely controlled by suitable instruments. So temperature is of the order of 450 degree Fahrenheit and this depending upon the binder. Heating element are properly placed to have uniform and same temperature distribution to the container. So replacing new air from outside done through blower so that moisture can be controlled. Then green sand cores. Handling then keeping them in mold is strictly followed by the rules and regulations for the casting process. So used for sand testing, moisture content, green and dry sand, permeability, compression, tensions, transfers and shear strengths and deformation strength, and compression test, and green and dry hardness, so green size distributions, etc. Then the pressure and volume and gases involved, flowability in staining points, so resistance to spilling, etc. So molding, sand preparation and moisture content determinations. The moisture content controlled practically all other properties of the sand. It is a varying properties since water content constantly evaporate during mold operations. Mold operations or mold preparations are used in these properties. So purpose of the molding cavity, so adding sufficient water to bring the moisture content to within the desired limits. So uniform distribution of water, accurate coating of clay to each sand grains. So moisture content determinations, the simplest method to try as sample thoroughly at a few degree above 212 degree Fahrenheit and to consider is loss weight of the moisture. So drying can be done in a thermometrically, so controlled over or in instrument designed for this purpose. There is one moisture tailor which will blow air through a 50 grams sample of sand that is placed in a plate. So testing and rammed sand, so green permeability, green compressions and a few other properties are tested when the sand is removed conditions. They are rammed should be within some ranges which is actually enhanced in the sand molds. The weight of the sand is placed into the hardened steel tube which is closed at the bottom of the materials. The weight used will be standard one depending on the ramming time and standard density is obtained. So once remaining is completed, the height of the rammed sand is evaluated and this should be equal to 2 inches in length. If it is equal to this height, required density is expected to be in the rammed sand. If the sand height is outside the range, the entire procedure will be repeated. So green compression strength is the sand solution is compressed between two plates connected to the ram of the universal testing machines. The load at which the sand sample breaks will give the compression strength. The same test can be performed at a high temperature is furnace to find the compression strength at the elevated temperatures. The deformation and green hardness. During compression test, the deformation of the sample can be recorded. The toughness can be obtained from this ultimate strength time it is corresponding deformations. The green hardness is the hardness of the rammed sand, that is measured by hardness test like Brenner hardness test. So spring loaded ball indenter is forced to the rammed and surface. The resistance of preparation will give the hardness of the sand surface and heating the metal. So furnace are used to heating process the metal to be molten temperature sufficient for casting. So total heat energy required is the sum of the heat to raise the temperature to the melting point, the heat of fusion to convert it from solid to liquid, and the heat to raise the molten metal to the desired temperature for curing. Total heat required in increase the temperature of the metal to the curing temperatures, such as volume of metal used for heating, then specific heat for the solid, then melting temperature of the metal, then obtained temperatures, starting temperatures, then heat of fusion, then specific heat of the liquid metals, then temperature of the curing liquids. The specific heat and other thermal properties of solid metals are constant and not dependent on the temperature, but not really true is especially if the metal under undergoes for the changing during heating. Sometimes specific heat of metal is solid and liquid states are assumed same but not really true. Single melting point which is not valid for alloys as there is temperature ranges. So between solid and liquid temperatures, the temperature should not follow for the same level for all the materials because the material properties varying for the every metals. So there are no heat losses to the environment during heating, but not related. Then gases in metals by using the metal casting process. The gases in metal is important in deciding the defect free castings. The metal castings gases may be mechanically dropped, so generated due to variation in the solidifications, different temperature or bases. So generated beyond chemical reactions is there. So gases generally present are hydrogen and nitrogen gases are mostly used in this process. For example, hydrogen based on the solidifications, hydrogen metal are divided as the split patterns. Most of the hydrogen removal techniques are based on the above equations. This is by reducing the partial pressure of hydrogen by bubbling dry insulation gases through the molten metal. Then hydrogen removals for non-ferrous metals and nitrogen, helium or argon is used. For ferrous metals and alloys and nitrogen cannot be used to form interiors that affect the grain size. In this case, carbon monoxide is used. So nitrogen removals. So carbon monoxide can be used a marked decrease in solidifications of nitrogen in ferrous metal leads to porosity in castings. So vacuum melting is used nowadays for preventing the solution of the gaseous metals. A good gating design should ensure proper dissolution of a molten metal without excessive temperature losses, turbulence gases entering. If the molten metal is cured very slowly, since time taken to fill the mold cavity will become longer solidifications. It start even before the mold is completely filled. This is restricted by the using heated metals. But in this case, solidifying will the problems is created. If the molten metal is cured very faster, it can enter the mold cavity. So gating design is important and it is depending on the metal and molten metal compositions. For example, aluminum can get oxidized easily